So I'm really going to talk to you a little bit about enterprise blockchain protocols. And when I do this, I'm trying to do it in such a way that it makes it easy for the non-technologist. You have to try to understand, first of all, what is a protocol? Well, a protocol is something that gives you rules to actually accomplish things. There's blockchain. Blockchain actually is a protocol. It has, as Gerard has just shown us, it has 4 elements, especially in the Bitcoin aspect, to the construction of each block. Each block has these 4 elements. It has the hash from the prior block. It has now the transaction root, the hash of all the transactions that are included in the block. It has a timestamp, and then it has the nonce, and that's the solution to the cryptographic puzzle that needs to be solved. So this is a protocol. And so what you have now is the question is what do you need for an enterprise protocol? Well, again, so now a protocol is basically these rules, these guidelines, these structures that you actually have, this architecture that exists for a blockchain. Now, these protocols provide that framework, which is the rules and guidelines. And then basically what you're looking at is that you have them so that it runs efficiently. That's what a protocol basically is. Now, why does blockchain need a protocol? Well, the first one is that there's no centralized entity that manages it. So you have to have some set of rules that manage it. The second is that the nodes need to be connected. So the connection of the nodes means that they're all participating in this rule structure, this ecosystem of architecture as it relates to this particular blockchain. The third is that the reason why they're doing this is that they have to have a maintenance of the ledger. The ledger is really what a blockchain is. Blockchain, as much as we want to think of it as a database, it's more simple than that. It's a ledger. It's a ledger of all transactions, and everything is time-stamped. And then, of course, the final rule that you need for a protocol is you need to have a method to validate these blocks. So why are we trying to look at enterprise blockchains? Well, the first one is that, enterprise blockchains are dealing with, all blockchains are dealing with things of decentralization, immutability, cost effectiveness, transparency, as well as speed. So when we think about these things, we try to understand ourselves and say, I'm trying to grasp what this technology does, and I can kind of understand this architecture that exists, but how do I actually measure it from an enterprise standpoint? Now, we're here at the Government Blockchain Association conference on infrastructure. And as we think about this, we should be thinking about how would government actually use these things? Well, they have to figure out what it is that they want out of this technology. So what I'm going to do is let's first of all try to put it into perspective. We see that Bitcoin is 12 years old. We know that Ripple is 8 years old. We have Ethereum that is 6 years old. We have Hyperledger, Corda, and Stellar all at 5 years old. We have Cardano that's 4 years old, and you have EOS.io. I forgot the IO on the slide. That is 3 years old. And you go, okay, I see all these blockchain protocols. How do I even determine what it is, or what is an enterprise-grade blockchain? And that's really the biggest problem. So what I've done, and I've been doing this for quite some time, is to categorize blockchains into generations. Now, I'm of a particular age where I remember back what VisiCal is. How many of you even know what VisiCal was? Okay, very, very few of us. It was the original spreadsheet, and it was built for the Apple Macintosh, actually Apple II. And people were like, wow, this is a compelling reason why I should buy this personal computer, because I can do the spreadsheet. Well, it was overlapped. A generational change occurred to it. And we had then had Lotus 1-2-3. I don't even think many of you even used Lotus 1-2-3. I remember using Lotus 1-2-3 thinking, oh my God, this is amazing. This was the best thing. It was so much better than VisiCal. And then, of course, it was surpassed by Excel. Not originally. Excel, when it first came out, was kind of a crappy little product. But it got better and better. And then, of course, Microsoft did something that was pure genius, and that is they bundled all of their Office apps into one and then made them interoperable. Well, that killed then WordPerfect, and it killed Lotus 1-2-3, and it killed Harvard Graphics, and it killed Firefox. Was it Firefox? No. It was a database. It was a small database called Firefox. Now I'm really dating myself. It was built by Borland, if you remember Borland. Anyway, so what we're dealing with is this. We're repeating this same exact process with blockchain. Now, with the exception of Scott Sternetta's building his first surety blockchain, starting back in 1991 with his partner, Stuart Haber, Bitcoin became really our Generation 1 blockchain. It's there. It was the first. It doesn't change very much. They've tried to do things. That's why we have like Bitcoin Cash and Bitcoin Gold and all the variations of Bitcoin. It is a Generation 1. It's the VisiCal of blockchains. Then we ended up with this second generation. This second generation platforms were really quite amazing. You started to think of things like, oh my God, I can put smart contracts into this. That is really cool. I can now think of this not as just a validating system of a ledger, but as a world computer. And you started to see these generational leaps in terms of what its capabilities were. Then you ended up with a third generation. Now, this is a little, people might dispute with me in terms of what a third generation is, and I'm going to define this for you in a bit, but there's third generation blockchains like Hyperledger Fabric, Steam, Ripple, and Corda. They were really third generation. They increased in speed and quantity and security and capabilities and governance, all the things that you really wanted. But really now, we are in a period where we are dealing with fourth generation blockchains. We have EOS.io, we have Hedera Hashgraph, we have Solana, we have Cardano. These are fourth generation blockchains. So let's talk about then what makes each of these different generations. So the whole problem of any protocol, especially as it relates to blockchain, is this trilemma. How do you balance out scalability, security, as well as decentralization? And every solution that we have right now is trying to balance these things out. So you have things like Bitcoin with its tens of thousands of nodes trying to do the mining versus things like Neo, which has only 7 nodes. Now, Neo is a lot faster because it doesn't have to deal so much, but this whole idea of where do you balance each of these things? Where does each of these elements in this trilemma come out so that you optimize it into something more important? So what I tried to do is this, and this actually showcases the generational differences that you have as it relates to blockchain. And that's talking about the speed aspect. That seems to be an important thing. When you think of Bitcoin, you think of, okay, it has a limitation, and we're going to talk about that in a second, but it has a limitation in terms of the number of transactions that it can do. It's limited by its block size, and it's limited by its block time. As a result, it has a hard cap in terms of how many transactions can occur in that day. The second aspect of it, though, is that when you think about speed, you have to try. It's hard to do because each of them uses different consensus mechanisms, but you try to find a way that when you are building these transactions, you're dealing with a similar number of parties when you're trying to calculate out transactions per second. You're also trying to have somewhat a semblance of a consensus algorithm that is similar. And then, of course, you also want to deal with what is validated and not validated. So let's kind of jump into this. Transaction speeds. We all know that Bitcoin has a limit of somewhere between 6 to 10 transactions per second. That's a hard cap. Bitcoin Cash tried to come out with a way of saying, like, you know what, let's increase the block size, let's increase the block time so it's faster, and it failed. There's been a lot of effort in terms of saying, how can we take this first generation blockchain and actually speed it up? Because if you're an enterprise customer, how do you build your business on a platform that doesn't have the capacity to service your clients? You can't do it. It's impossible. And the moment you try is the moment that you've also put yourself in the graveyard of failed businesses. The next one, though, is we get this Ethereum. Now, Ethereum is that generation 2. It literally doubles the transaction speeds of Bitcoin. We're now going from 15 to 20 transactions per second. It's doing it with roughly the same size, a number of miners. It's using the same protocol, proof of work. Now, granted, they're trying to migrate to proof of stake. It's questionable as to whether it will happen or not, or whether it will be successful or not, but they're trying to actually address this idea of scalability. Now, both of these protocols have this idea that, you know, we could come up with something like, let's call it a lightning network or a sharding or something really cool. But all you're doing is you're taking all these transactions, you're moving them off the blockchain. Now you're opening yourself up to manipulation, fraud, and everything else that you don't want, so that you can feed it into the blockchain because the blockchain has limitations. What you now see is this third generation. And if you see the doubling, so from Bitcoin to Ethereum, you double the number of transactions per second. But now all of a sudden you're having almost a 10x increase. Corda comes out and it's doing 170 transactions per second. And you say to yourself, wow, now that is really getting to be something important. Now, I'm not disparaging any of these platforms. Ethereum is the dominant platform for DeFi. It is the dominant platform for a lot of dApps. It is the de facto platform for all cryptocurrencies when they are first launched, for the most part. But it has a problem. It can't scale. And the question is going to be, is it VisiCal or is it really Lotus 123? Because there's new protocols coming and they're getting bigger and better and faster. Then you can end up with things like Hyperledger. Now, it 10x's Corda. If you think about that, now all of a sudden we're dealing with something that, of course, is not a public blockchain, but a private blockchain and a private blockchain implementation. But now we're approaching the phase where we can actually run an enterprise on a blockchain. Then you introduce a fourth generation blockchain. Now, within the fourth generation blockchains, you have a lot of scaling. These people focused on scaling to an nth degree. They really wanted to say, how can I really, really grow this business? Well, EOS.IO has a range of somewhere between 6,000 to 20,000 transactions, but has the capacity to actually go to about 50,000 transactions per second. Now we're almost getting to the point where we could do, algorithmic trading on a blockchain. Because, face it, that's kind of almost the benchmark. We have to be able to do as many transactions as possible in the shortest amount of time, but we still want to have all the things of security and the immutability, but I'm struggling with that word today, as well as the security that a blockchain protocol can actually provide. Then we have now this brand new one, and I say it's only brand new because it's only new to our awareness, and as Solana. They came out of the gate at 50,000 transactions per second. You're going, my God, why would I be on Ethereum with 15 to 20 transactions per second when I can be on one of these fourth generation blockchains and really be, scaling up? And then our last example is our sponsor here at this conference, and that is Cardano. Now, Cardano had a problem when it first came out. It came out at about 170 transactions per second, but they've now released their new protocol, which is called Hydra. And it theoretically goes up to 2 million transactions per second. Now, you're not going to have capacity problems. You're not going to have things like orphaned transactions because there's communication errors between groups of people globally in terms of how do you do it. You're not having a cap. So if you think of going back to the Bitcoin, they only have the capacity to do 400,000 transactions a day. A day. These are companies that are doing that in minutes or seconds. Why would you ever not choose an enterprise-grade blockchain for your implementation? Now, in comparison, let's look at companies that we're familiar with. Let's look at PayPal. PayPal comes in at a massive 193 transactions per second. It's a billion-dollar, multi-billion-dollar company. 193 transactions per second. You know, when you look back at, you know, Ethereum or Bitcoin, you go, well, it's better than that, but, you know, it's all relative. Or something else, Visa. Now, I tried to look up what was their cap rate a number of different times, and the one number that almost consistently came up is they have a capacity of about 1,700 transactions per second, which is about similar to what Hyperledger Fabric does. So when you start to think about these things, and you're thinking to yourself, okay, I need to have an enterprise-grade protocol, blockchain protocol, that balances the trilemma issues of security, decentralization, and speed. But it's hard to make a decision on decentralization. What does decentralization mean? Up until recently, 80% of all Bitcoin transactions were mined in China from a geographic location. If you looked at the pools that mined it, 80% of the pools that mined Bitcoin were five pools. Is that really decentralized? Maybe, maybe not. What I'm trying to do is to raise your awareness. I'm trying to share with you exactly what you can think about as you start to think about not only blockchain, but what is an enterprise-grade protocol that I can use. Now, we are dealing with the second element of that trilemma, and that is governance. Now, governance provides us with the ability to do things. Now, in an ideal world, governance allows us to freeze and fix broken applications. It also creates this role-based permission system so that we can go in and assist people in the process. It also gives us the ability to have parallel execution, asynchronous communication. You can have web developer kits that are out there. You have self-describing database schemas. You have self-describing interfaces. You have dispute resolution. Well, I teach a course on Bitcoin where I talk about dispute resolution. And some of the examples I give are people who send transactions to the wrong person. What do you do in that situation? Well, in the past, or still on the Bitcoin blockchain, if you send your Bitcoin to the wrong address, it's gone. It's gone forever. Or even worse, what happens if you manage all your Bitcoin very, very appropriately and you die? How does your family actually access this? You have no method for it. So here we have this. That's the final thing that I want to leave you with, and that's this issue of finality. Finality, in my mind, is rarely spoken to correctly. We all talk about what Bitcoin is, and we talk about transactions and the building of the blocks and all this other stuff, but that has nothing to do with finality. Finality is to me, it's the secret aspect of Bitcoin that people are afraid to talk about, and that is how long does it take for the blockchain to become immutable? See, I did good with that word today. How long does it take? Well, let's look at some of these things. We have Bitcoin, which uses the proof of work consensus. Block times roughly, Gerard pointed that out correctly, roughly every 10 minutes. It has tens of thousands of validators, but it can take 60 minutes. It has to have 6 blocks. 60 minutes for finality. Well, can you imagine you go into Starbucks and go, I want a grande coffee. Can you please make it maybe Americano? I have to wait 60 minutes before you give it to me because I'm unsure whether you're going to get paid. It's unacceptable. The secret of Bitcoin, by the way, this is an aside, I'm stepping off to the side here, is that originally it was thought of as a currency. The moment that it showed it was incapable of acting like a currency is the moment that it became a store of value. So never referred to Bitcoin as a currency anymore because it doesn't have the capacity to be it. But that's my aside. Going down the list, we have Ethereum. They have blocks every 15 seconds. They have tens of thousands of validators, but it still takes 6 minutes. They have to have 25 blocks built before you have finality. Now, Ethereum with Casper, which is when they move to the proof of stake environment, they're going to have now very fast block times, every 3 seconds. But unfortunately, now their finality time goes from 6 minutes to 15 minutes. Now, don't ask me why. I tried to research that to the best of my ability. I've never been able to find out about that. You have NEO that comes in, or EOS.IO. They do a half second. They have 21 validators. It takes 10 seconds in the existing protocol to come to finality. They have now a new protocol that comes out, again, every half second, 21 validators, and they actually achieve 3-second finality. You have NEO, same thing, essentially 2-second block times, 10-second finalities. Solana comes in at 400 milliseconds, so you can essentially, it's a little less than a half a second, but it takes 10 seconds. They have to build 5 blocks before they have finality. You have Solana, that's what I just did, and then Cardano that has 20-second block times, 21 validators, and it takes 5 minutes for finality. What I'm trying to bring up, yes?
I just got a message from Louise that it's not 3 seconds for US, it's 3 minutes.
Repeat the question.
3 minutes for?
For EOS.IO.
No, it's only 6 blocks. It's wrong. He's wrong. No, absolutely wrong. I spoke to Dan about this. She's an associate of mine, so she can dispute me. None of you else can, but she can. All right, all of you can dispute me. It's okay. So really what we're trying to do is this, is we need to look at enterprise blockchain as a solution. And you have to balance these things out. You balance out the governance, you balance out security, you balance out speed, and you're giving up parts of some for another. But as you start to think about what you would need or what a government would need, to me, the perfect first deployment of blockchain for the US government would be in like the US Patent Office. It's brilliant there. What did Scott tell us about this morning? He said the biggest problem that he thought was unsolvable is how do you manage documents and prove those things? Well, what is a patent application other than just a mass of documents? Perfect example where blockchain could come in. Again, you would have to choose something enterprise. But again, what we're looking at is speed, governance, security, and of course, finality. As before, this is my contact information. Do any of you have any questions? Yes, a bunch of them.
We'll
Mike's
take
over
this
here.
one over here first. Saw your hand first.
Hi, Andrew Zaverzin in the office of Senator Todd Young in the U.S. Senate. On the issue of transactions per second, I think this is a very important point. And just in terms of contrast, SWIFT network does about 30,000 transactions per second. Credit card transactions are about 700,000 transactions per second. So when we're
Overall, for all
credit card
yes.
transactions, about 700,000 per second. So it's interesting.
And that's capacity. I mean, that's peak capacity. It's not their standard.
That's average capacity.
No, peak. That's peak capacity. Trust me.
Okay,
I've
you've looked at
this.
I defer to you.
Okay.
But I think the broader question, though, is you get reticence to adopt a technology that does not seem to be mature enough to handle capacity, particularly in the financial sector. And especially when we start talking about derivatives or options tradings or anything like that, you get concern about What happens in moments of great stress or when there's tons of transactions all at once? You've seen this even recently with some of the crypto markets not being able to handle the capacity as it comes. So, I mean, it's encouraging to hear about Cardano and Solana and things like this, but how do you advise policymakers and regulators who are reticent to even step a toe into the conversation until it's matured to a better extent?
That's a real simple answer for you, and that is that the financial markets have shown the way. There's been many, many times when the capacity of, say, the New York Stock Exchange is exceeded by its ability, and they shut down. It is always going to be an arms race in terms of how do we scale up. And that's really the operative word. How do you scale something that is going through rapid iteration? And the answer to that is that you try to take the best that's out there and that you hope that in the future it gets better and better. And again, why I brought up that original example of VisiCal, Lotus, Excel, is because we're going through generational changes on this technology. This technology is so immature. We can think of it, I mean, those of you who have been in it as long, and again, no one exceeds Scott Stornetta. He's the guy who thought it up. I mean, come on. But the rest of us, we've been in it 5, 6, 7 years, and we've been thinking about it for that period of time. And we're in its infancy. Think of where the internet was at 5 years old. I mean, it was like kids with crayons drawing things, and we're going like, wow, that's the coolest thing in the world. We would never tolerate that today. Let's look at it when these 4th generation blockchains become either a 5th generation blockchain or they become 20 years of maturity, where a lot of these issues then become resolved. It's not just speed, it's also the governance model. The governance of the ability of going in and saying, I can correct a transaction, or I can fix this, or what happens if I lose my password? I mean, there's a million stories of people who lost their password. There's a guy, he was the CFO for some major corporation. They have $300 million in Bitcoin that they can't access because he can't remember his iron safe. He had what is it? Right. He can't remember what the password is, and he only gets 10 chances, and he's already taken 6. Hundreds of millions of dollars in the balance. Try to remember. So, other questions, please.
Hi, I'm a management consultant. I've advised a lot of Fortune 500 companies.
I'm sorry.
And so the reason I'm asking this question is because when a larger organization decides to adopt an enterprise-grade blockchain for whatever reason, supply chain or from a Walmart standpoint to traceability of products, how easy is it to port from one to another? Because they're constantly getting better.
It's not even just getting better. Think of just the languages that are used for smart contracts. Ethereum has Truffle and Solidity as their things. There are some ports that other blockchains are making for using those. And again, all they're using is the EVM to mirror it. That's not happening. You have blockchains. I mean, EOS.io uses C++ primarily. Each of these are different languages. You're not going to port them conveniently or easily across blockchains. We're not at the point where we have a unified file system, which, again, that's what Microsoft's genius was. Their brilliance was let's create something that is then readable by our other products. And that's what made them, the trillion-dollar company they are today. But that doesn't exist in blockchain. It doesn't exist at all. Yet, right.
Bryant, this is great. Thank you for this. My name's Joe Bagnano. I'm a co-founder of a blockchain-based startup which actually provides the capability to get at those underlying assets when you've lost your password or your private key. But my question
Craig
is,
Wright wants to speak to you.
yeah, we've spoken to a lot of folks. Spoken to a lot of folks. The question I had was with regard to the examples that you were giving in terms of those, and I think you were alluding to it a little bit, particularly as you were talking about U.S. government or other governments adopting some of these technologies and which to choose. Because it would seem almost to the extent, well, I'm just going to go with the fastest. But it seemed to me that you were alluding to the fact that it also depends on kind of what is appropriate for what you're trying to apply it to, and potentially that some of these protocols may actually have some disadvantages, so you may choose one over the other. I wanted to understand if that was what you were trying to say. And
Sure.
If you could expand on that
I
a
mean,
little bit.
again, it's not just speed. It's the trilemma of issues. You have issues of, of finality. You have issues of governance. You would have to make those things. I mean, there's no way the U.S. government can run on the Ethereum network with CryptoKitties out there. Just as an example, when CryptoKitties was released, it sucked up 25% of the transaction volume. Okay, you're a business, you're trying to run your business on Ethereum, and you're going like, wait, one game is now putting me out of business because I can't do transactions? Now, again, Ethereum has Ethereum Pro, we have Quorum, which are private implementations of it. It's still governed by a limitation, of transactions. Yeah, I mean, if I was the U.S. government and I'm going like, okay, I'm going to make something up here. Social Security disbursements. How many do I have to do? Well, can I do that on Bitcoin? No. Can I do that on Ethereum? No. You know, I'm having to look at one of these fourth generation blockchains. And then I'm at least now dealing in the realm of what I can do from a transaction standpoint. Now the question is, well, of these things, can I actually give up a little bit here and get a little over here? And again, those will be trade-offs. But the idea of this is really important. We too often, in my mind, confuse public blockchains or permissionless-based blockchains with being the gold standard, and that's not the case. Permissioned or private blockchains are really where the value is going to be created out of this technology. I mean, God knows everyone talks about crypto. I mean, everybody talks about crypto, and every time there's a price increase, it becomes a very loud roar of people. But that's not where the value is in Bitcoin. Crypto is just a single application on this infrastructure technology. Any other questions? Am I doing okay, Virginia?
Yeah, you're good on time.
I've got an equation for you.
Okay. Go ahead.
I want to interview her after this, just so I can verify your info. Raphael from Minnesota Blockchain Initiative. I had a question because the conversations that we have are blockchain is the plumbing, the infrastructure of what Bitcoin made not necessarily viable, but a lot of people took notice. And we talk about in our office, what's the narrative that we're crafting around why this information, why this utility, blockchain, is going to impact your life. And at every age, there is a way to do that. And, you know, I'm staying in a stranger's home. I was brought here today in a stranger's car. Now, if I told you 20 years ago that you would sleep at someone else's home, whether or not they're there, and that you would let a stranger pick you up and drive you to their house, anybody who has a parent would have said, that's ridiculous, you'll get murdered. And this doesn't happen. We've allowed trust in a third party, Airbnb or Uber. These companies are now the largest property rental companies in the world, and they own nothing. We're now able to take that, and when you're talking to a government or when you're talking to a management, consulting person, if they were able to say, hey, remember when Amazon only sold books? Remember what Jeff Bezos looked like? I don't know if you've seen the meme, but I'm Jeff Bezos, I sell books.
He was still rich, though.
Yes, he was still rich. But as the technology changes, there's not anybody you can ask, I don't care what your age is. My grandmother's 87, and she says, I don't know what blockchain is, but I know that it's going to be something because I didn't know what the internet was. but now I can get satellite James Bond phone on my maps on my phone, and it's super cool. So when you
Your
ask them,
mom gets James Bond maps?
that's what my grandma thinks she's a super spy because she can
Oh,
see
cool.
satellite images on
So
her
what is
phone.
your question? What is your question?
The question is, what do you think is the best way, in a very succinct, when somebody asks you, why should I care about blockchain? What is your short elevator pitch? You've given it 100 times. What is your answer?
Well, I've not given that elevator pitch ever. So why blockchain? Because blockchain puts trust back into society. That's really it. And I think my time is up.
Thank you.
Thank you. Ah.